Okay. YouTube is also okay. Good. So start session. Yeah. Uh, so good evening, everyone. So we'll start the session in a few, within a minute. And yeah, okay. So let's start with our, one second, I just skip some small things. Yeah. So this problem statement is the following. Whiteboard.
Sir, you're not sharing the screen.
Yeah, I'll share, one second. Just let me start the whiteboard actually. Yeah, okay, start. I'll share the screen. Your interest. Okay. So is the problem statement now visible? Okay.
Yes, sir.
Yeah. Um. So good evening. Well, this is the week 7 of this NPTEL PDSA course, and I am Shovik. So let's start with our session. So this is our first question. Giving the following the permutation of A B C D E F G H I. Uh, what is the previous permutation in the lexicographic dictionary order? And we should write your own answer. So this is our what is called is the oops, what is happening? Anyway, uh, so we'll copy this and let's paste it here. Have a new whiteboard. And so this is our lexicographic dictionary. I think similar problem we have in our uh, assignment also, right? Um, so let's write the first. So here we have to find the previous permutation, correct? So what there was to two, I think. Uh, so our thing is F J A D C H B E G. This is our uh, string which you have to do the permutation, correct? So uh, here, so since we are doing this is just the opposite of what was shown in the video. In the video we had the next, we are seeing previous. So first where we have to see is that um, what what is the, as from the, if you start from the end, what is the suffix that can be ascending from the last from the end, right? So here first is I is greater than, yeah, uh, yeah, so I is greater than G, correct? Then G is greater than again E is greater than again B. So we are going to the descending order, sorry, descending order. So yes, is descending order, okay? So we'll go back in the descending order. If we had to do the next, then we have to go for the ascending order. Here we are going for the descending order. We can see that I is greater than G, so it's descending. G is greater than E, descending, greater than B. But when you are coming to H, it's getting, yeah, it's getting increased. So we don't want this. Now, so this is where we have to stop, correct? Now what we have to do is we have to replace this H with something. Now what is the something here? Here we have to do is from the right side of the H, we have to check is whichever is the largest H just before H. Okay, sorry, largest, yeah, largest H. Just one second, I'll just check this thing once. Yeah, correct, correct. Yeah, so we have to find the largest H before the, sorry, largest alphabet just before the H. Okay, so if we do like this, oh, G E F G H I, correct? So we have E F G H I. Okay, so just before H, the largest alphabet is G. I just one second. Just a second, huh? Got some. Yeah. Reshare the slide. Yeah. And okay. Yeah. So where was I here? Yeah. So we have to find the largest number just before each. So that is G. Now here then we have to, what we have to do, because when we ascending, if we are doing it the next, we had to say the smallest one, that is just before, just after H, right? So now we are doing the opposite, next previous, so we will do G. So this G we have to replace with H, correct? So now the remaining part will be same, F J A D C. Now H will be replaced by G, and we'll see that B E H I. Now this one we have to again do it in the opposite order, right? On the, now we have to do it on the descending, on the ascending order, to this. Okay, if we do this in this, if we do sorry, descending order again, wrong. Yeah, right, descending. Yeah, you have to do descending order here, this one. So then we have to write F J A, the right side. Okay, this is the right side. F J A D C G. This we have to order in descending. So if we order in descending order, first will be I, then we will have I H G H I E F B. So this is our correct answer. F J A D C G I H E B. Okay, let's see if we have the correct answer here. Yeah, so this is our correct answer, F J A D C. Let's copy this one, yeah, and paste it here. F J A D C G I H E B. Okay, so this the previous, so from this we have this. This is the previous one. So you have to just do the opposite what you have done in the next.
But sir, it is not in the lexicographical order. The numbers, the digits are not.
No, it's lexicographical. So we have not, still not sorted it. If we final sort, after final sorting, we'll have A B C D E F G H I, right, in lexicographical order. This one, this I am just doing the previous, like the previous permutation.
Okay.
Sir,
Yeah,
please. Would like to know the question exactly what it is. I'm a bit confused in that.
yeah,
So
this is
please.
the question.
Yes, sir, please. I also want
Yeah.
to read it out.
Yeah. Uh, Given the following permutation from A to I, what is the previous permutation in lexicographic dictionary order? Write your answer without any blank space. So this is the one we have to do. We have to find the previous one.
So this is the input, right? FJAD.
Yeah,
Then
this
they
is the
have
input.
asked for the previous
Previous,
permutation of
previous.
this.
Yeah.
So more than coding, we want the explanation how it has to be done, then the coding, sir. So आपने समझाया है, but still it's not clear. Will you explain it once again, sir?
Yeah,
This
sure, sure,
whatever on
sure.
the whiteboard.
Excuse me, sir.
Yeah.
Sir, can you one explain one time what is lexicographic order?
Okay, it's a dictionary. I mean, dictionary order like A, B, C, D, E, F, G, H, I. I'm not sure about the core computer science concept about in the lexicographic order, but it's some
Oh,
that
okay, sir.
I'm not
So,
sure. But
okay,
the lexicographic order means just dictionary order. I mean, if you want to do like in dictionary, we have from A to Z. So I think that is the one.
okay, sir.
Hello.
This means we just have to find one word previous to that given word, like
Yeah,
that.
yeah, 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 yeah.
Okay, okay.
Hello, sir.
Yes, sir. Yes.
Please, one second. Tell me. Explain, please, sir.
Yeah. I'll explain this once more. Okay.
Okay, sir.
Yeah. So let's just close this one. Okay. So what we have is the following, right? F J A T C H B E G and I. Okay. Now you have to first see in the so while doing the next permutation, we have to see in the ascending order, right? From the sub what is the suffix that cannot be incremented. Now here we will see what is the suffix that cannot be decremented because we are seeing previous. So suffix that cannot be decremented. Okay, fine. Now so now we have like this. Now so from we'll see the if we can decrease it. Okay, so first I to G it's decreasing, so it's fine. So I to G is fine. Then we see if this is decreasing. Again it is decreasing, right? G to E. Then again another time it's decreasing. Okay. So now, but from we are doing to B to H, this fails because B to H it's increasing. So now here we have our sorry. Here we have our uh, the first one that there where the uh, order is not decreasing but increasing. So now, like similarly what we done for next in the video, we have to replace it to a with a something that is okay. Please turn off your mic. Okay, we'll have mute. Okay, fine. Yeah. So yeah. So then so we have to now replace. Okay, right. Now what when we did on the previous one, what we tried to see now if we consider this part E, so it is B E G I. Now H will sit between G and H, so here my H is here. Okay. Now previous one when you were to do it for the next, what we considered the next the larger than H but the smallest larger than H number. Here we will consider the opposite, which is smaller than 8 but largest in the left sequence within this particular sequence. Okay, so in that concept we have G. Okay, so now if we again write it on the next one, so we'll now consider F, J, A, D, C. We are replacing H with G. Then again we have B. Sorry. Okay. We are replacing H with G, so we'll have G here. Then we have B, E, whatever we did then, and I'll put the H here. Okay. And now what we'll do is we'll have to reorder this particular thing in the opposite order. So this particular portion what we have here, we'll replace it with in the increasing order, sorry, in the decreasing order. So now this side it will decrease. Okay, now if we do it again once more, F, J, A, D, C, G is there, and we'll decrease it, so we'll have it I. Now the first one, so in the decreasing order, first the biggest one we have, which have I, then which we have H, and we have E, then B. So this is our answer. Okay, so this is how you had to do. If we had to do next, then next will be a little, will be easy because we have just I here, so we have to just change E and I and G. I hope now it is clear how we have to do, and yeah. Okay, so let's see the second question. I'll remove this part.
सर
Yeah.
ऐसे रिलेट करने वाला कोई रियल लाइफ का एग्जांपल कैन यू सजेस्ट अस?
Not sure. I am not sure about real life example of this particular thing. I mean, this here itself is a real life thing. Real life
या
thing.
डिक्शनरी.
Dictionary, right? So
Okay.
I'm not sure if any like real practical example of this
Sir,
lexicographic.
we understood you traversed till we get that H, sir. Then later on, once we get H, we replaced it with G. Then at the end, आपने वो जो last part का जो list है, that you reversed it back. So that
Yes.
part, why we have to do last
Yeah.
part?
Yeah, so that part we are now going in the opposite, so we have to go from the largest permutation order, right? So the lowest number should be, so when what is the smallest permutation is this, correct? A, B, C, D, E, F, G, H, I. This is my smallest permutation, right?
Yeah.
Now from smallest permutation I am going to the largest permutation, which is just opposite. So I, H, E, can someone turn off the mic?
Yeah, yeah.
Okay. I, H, G, F, E, D, C, B, A, right? This is the largest permutation. Now I am going to the previous. So from the previous, if you are going to the smallest one, we should have the smaller number. I have just deleted it. I'll just copy it once more. Second. Yeah. So if I copy it once more here, this one, and the result also, we just copy it. Yeah. Copy and So yeah. So when I'm going from the largest one to the smallest one, because now I'm going in the back. So considering this is larger permutation than this, correct? If this is larger permutation, the smaller number just after G, the smaller number should be on the back, because here A is always in the behind than B, right? A is before B, like that. So the smaller one should be before. So that's why I'm changing it. Now you see, if we consider it now the previous of this one, now we have another option, yeah, another way. Yeah, so some more smaller of this one. So that's how we are doing it. Is it better now? I hope.
Yes, little bit better, but
Huh.
we'll just proceed. I think we'll understand.
Excuse me, sir.
Yeah.
Sir, can you explain the smallest permutation and largest permutation ones?
Yeah, it's
What the
just it's just it's just
difference?
not in small parts. If we have a dictionary number of, just now I have just removed one second. Yeah. So if we have a dictionary of order, so A to I, if we have a dictionary order, so
Hmm.
smallest permutation is when the all the numbers are sorted in a ascending order. The largest permutation will be when all the numbers are sorted in a
Descending order.
descending order. Correct? A descending order. That is the difference between smallest and largest. So after there is no, sorry, there is no next after this, and there is no previous after this.
Okay.
Okay.
Okay, sir.
Hmm. Okay. Okay, we'll go, or I'll just have a new order. Yeah, let's go into a new order. Give example of 3 or 4 characters. Yeah, actually, there's someone suggested, right? So if like we have considered just ABCD here, ABCD, and if we want, this is the smallest permutation, right? This is the smallest permutation actually. So you have to go for the largest one. So let's see, if you have the largest one is this DCBA. Now the previous one of this will be, so we cannot move this after this, right? So we have to go, it's not decreasing, so what you have to do, D C A B A B, right? We are just changing it because we have to change the order. Now your B to A you are not decreasing, you are decreasing, but A to C you are again not decreasing. Now A B C, right? This is again A B C. Now what we have to replace? Yeah, so C we have to replace with B, right? So D A B C. Now again we go like this. We are going again, I'm going previous one, right? So then we have to replace again, A B C D is there, so then D and C you have to replace. Oops, sorry. So we have A B C D. Now you understand why we are considering this. Why we have to do it, this part we have to set in ascending order, the previous part.
Sir, but in the
Hmm.
question, you explained that we will replace, like we have to replace B to C here.
Correct. B to C only we have replaced here, right?
Yeah.
Yeah, so okay, I'll just do one thing. Hmm. So first we are increasing in the, this is my largest permutation, right? I'm going to the previous permutation. So
Yes. No, sir. In like third line,
hmm,
in place of A, we should write B, na? Then
yeah,
AC. So in third line, the order should be D, B, A, C.
why?
Sir, because like you explained in the
Hmm.
question, we
Okay.
replace G with, we replace H with G, and like
Okay,
and
let's
wrote
see in the
the
third
other
one.
thing like normal.
This one or this one?
Sir, third one.
This one,
Third one.
right? So let's see.
DABC.
Okay, so let's see. D, C, A, B. We have now. If we go, the previous one is we have like this. So B to A is decreasing. A to C is not decreasing. Okay, so A to C is not decreasing. That means we
Yes,
have to
sir.
consider A. So this is our one. Now we have A, B, C, D. This is my C. So what will exchange first? D, C. Sorry, D, B, A, C. Correct.
Yes, sir. Yes,
Huh.
sir.
So now where we stopped here? Here, but we have to go. Sorry, we have to go from this one. Yeah, from this one we have to go from this one. We have to arrange it in the increase. This side we have to increase, right? A, B, C.
Yes, sir.
This side you have to increase. So like that, if after D it comes A, then it comes B, then it comes C. That's why
Okay,
D, A,
sir.
B, C.
Okay, okay. Okay,
Correct?
sir. Okay. Yeah, yeah.
Okay. 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 We'll go to the next question. Assume we have defined a class node that implements user-defined list of numbers. Each object node has node of type has two attributes, node.value and node.next, with usual interpretation. So whatever we have done, we have seen in the video. We want to add a function sum to the class node, which will compute the sum of values in the list. An incomplete implementation of sum is given below. What should we put in place of xxx and yyyy? Okay, so let's copy this first part. Let's copy this part first. Just paste it here. Yeah. So yeah. So see. So when the self dot value, when there is an empty list, so node is just a list, correct? Whatever is self is a list first of all. So in the node itself is a list. Okay. So first when the self dot value is none, there is none, so we will return 0. The sum of the empty list is a 0. Now when self dot next is none, so now say I have a list of 1 comma 2, or say just 1. Let's just make it 1, just 1. Okay, we have a list of just one element. So at first element, now when it has first it has taken that some just one, and the self dot next is none, so there is no other value. So what it should return? Xxx. So what should return? This is the self is now what? Self is equal to now actually 1. So what it should return? Self
Self of zero.
self of value, self dot value. This is the sum, right? We don't have any number, so it is self to self dot value.
Yes.
So it should return self dot value. So what is so now you have got the first answer, right? So what is xxx? Xxx is equal to just self dot value. Sorry for the bad handwriting. Just write it. Yeah, self dot value. So I got the xxx. Now y. Okay. Now in next case, what we have? We have 2. Okay. So now it is a recursive. It will be a recursive call, right? Now what it will do? Return yyyy will be actually when it is doing next when we are going, we are actually calculating sum, means we are calculating self dot value self dot value of the previous one plus the self dot value of the current one, because we are considering, so now if we are considering from 1, if we are moving to 2, correct, then we have to again call the sum and see that if next value is none. Till when the next value is not none, till when we don't reach the end of the list, we cannot return. So then we have to do a recursive call. Now let's see the options here. Oops. Replace xxx by 1, which is not true, of course. These first two are not true. Replace self dot by self dot value, correct. But y is not 1, correct. So what is that? We have to again call the sum for the next value. Sorry. So when the self is 1, when the self is 1, we have to call the self dot next, okay? Then self dot next and dot sum, because again it will check if the next sum is 0. If the next sum is not 0, then it will not return me. Then again it will call self dot next dot, again it will call self dot next dot sum. So if it had a third number, say C3, then self dot next dot sum will call again 3, correct. When you call self dot next dot sum, that time it will at 3, when it is at 3, it will see that okay, self dot next, after 3 there is nothing, so it will return xxx self dot value, so that is 3 plus, now self dot next of 2 will return actually up again self dot value 2, then again it will return 1, correct, because what actually sum is just 2 times we have called self plus self dot value plus self dot next dot value plus self dot next dot sum of values. It's a recursive call of the sum. So our answer will be, of course, this one, the replace xs by self dot value and yy by self dot value plus self dot next dot sum, because till self dot next is not none, we are recursively calling sum to give us the self dot value. So self dot next dot sum is again giving recursively next of the sum, like that. It is clear? Okay. Okay. Suppose we add this function foo to the class tree, and that implements search trees. For a name my tree, there is a tree, whatever the binary tree, whatever we had done. What would be the my tree dot foo? What would my tree dot foo compute? Okay. Def foo self, if self is empty, return 0. If self is real, return self dot value. Else return self dot value plus self dot left of foo plus self of right dot foo. What will return? Sum of elements of the tree, the maximum sum across all root to the leaf paths in the tree, the leaf of the longest root to leaf path in the tree, and number of root to leaf paths in the tree. Can someone tell me the answer? What is the answer? They're just seeing this. Okay. No answer.
Maximum sum across all route to leaf path in this. B.
B? Yes, correct answer. Correct answer. I'll explain. This is the correct answer. Okay, we'll have, okay, this thing is good, so we'll have another whiteboard. Okay. Okay, so let's copy this first and see what is happening. Okay, so we have defined foo self. If self dot is empty, we will return 0. So when there is no foo, like if it is an empty tree, nothing, will return 0. If I think the, yeah, uh, the indexes have gone actually here. I think can D if self dot elif self dot is leaf, then return self dot value. See, the indexes are not correct there, so I moved here only. And else return self dot value plus max of self dot poo. Okay. Okay. So first, when there is an empty list, we don't have. Now when, if it is a leaf, so if I have a binary structure like this, it will have a node. This will have something like a leaf. Okay. Now I am searching for the in the tree. So first my number will be a root, my root. Then I'll go down in the tree. This leaf has so this has two nodes, right? In this root has leaves, two nodes basically rather. So one is the right, one is the left. Okay. So if it will choose between the self dot left dot foo and self dot right dot foo between the maximum. So between these and this, it will choose this is maximum one, and actually it will not choose now, it will choose later. Next it will call the next left, it will again call foo. Now foo is if it is a leaf, so here two leaves will be there, we'll move here. If it is a leaf, then again it will return the self dot value. Sorry, this is not a leaf here. So again it will call and see the if the this is right or this is more. So it will choose the maximum of this, which should be this between two. And here if you choose, and here if you go, this one root but this one leaf, so leaf will return this value itself. Now next foo will choose between these two, maximum of these two, so it will go here like this, maximum of these two, and maximum of these two is this. So this plus this, sorry, this should go here actually, this should go here, then it should go to here directly. So it's basically the maximum sum across all root to the leaf paths in the tree, because this is a max option. So whenever I'm calling the left dot foo or right dot foo, if there is it is a leaf, there is no left right, so it will return me the value. If it is a node, it will choose between the maximum of the nodes. Okay, this is the maximum sum across all roots to leaf paths in the tree. Okay, this is the last question for the day. Yeah, so the pre-order traversal of a binary search tree integer values produces the following sequence. And what is the value of the right child of the root of the tree? So we have to draw the root. Now for drawing a root, So I think pre-order traversal was not taught in the class, most probably, right? So this is very interesting. So when we so you can build a tree when we have two ordered trees, either in order, pre-order, in order, post order, or in or post order, like two. So there are three types of representation of a tree. First one is a pre-order. Pre-order considers always this format. First we will have a roots, then left, and then right. Okay. The in order considers the following: left, which are always decreasing, then root will be another in the somewhere in the middle value, and right, which is always increasing again. So in order trees is actually a short form of a increasing order. Okay. And then we have the last one, the post order tree. The post order tree is right, opposite of the pre-order, basically right, left, root. Now you can make a tree only when you know either two of these, either pre-order, post order, pre-order, in order. Now from pre-order you can easily get the in order, because in order is always in an increasing order. So okay. So we have, I don't know why it is not. So 30, this is our pre-order tree. Okay, I am writing PO, pre-order. 35, 23, 26, 46, 40, 39, 41, and 52. Okay, I decrease it a bit because I need some more space for building the tree. And so what will be the increase in order tree? We can easily find the in order, right? Because in order is always increasing. So 23, first smallest one is 23, then we have 26, then we have after 26 35, then we have 39, 39, 40, 41, 46, and lastly 52. This is our increasing tree in the increasing order, right? Now what I have told here, that pre-order always first gives me the root. So 35 will be the mother root of that binary search tree. So we'll make the tree. Okay. So this is our first mother root, 35. And in order, root should be somewhere in between. It may not be exactly in between, because you may not have a left and right adjusted tree, right? You cannot have a there are more elements in the left than in the right. So here is our root here, 35. Okay. Next we have to see, now you can write 23 and 20 now. So this is our left part, so this thing will go in the left. Now you can write always like this while making a tree, this in the left part. So 23, 26 is kind of a node, right? Now in tree we always have a decreasing order when we'll go by the tree. So how actually the node, how it would look? So it will actually look, can you understand, 23, 26 in the left, so I am going in the left direction. So you can write 26, one root, correct? Sorry, I'm doing a mistake. Sorry. Yeah. So you have to now check. So 23 and 26 here, correct? So now you have to check that if what is root. Now again in the pre-order, root, left, right, always the order. So after this root, this is our again a next root, because root comes first. So what we will have here? 23. Correct. Now 23 and 26 both are in the left, so it should 26 must be a leaf. Okay, because and since 23 is greater than 26, so 26 will be on the right. Is it clear? Hello, am I audible?
Yes, sir.
It's clear, right? How I am doing? I am seeing both the pre-ordered tree, right here, both the pre-ordered tree and the in-ordered tree to make the tree actual tree. Okay, so after in pre-ordered tree always root. So after 35, the next root is 23. Now here I know that 23 and 26 both are in the left side, so we'll write 23 and 26. Okay, so our three things are done from the pre-order priority we have made. Now we'll
Sir, how
consider.
did you know 35 is the root element? I mean,
Yeah, in pre-order, it's a default order is that the first one, the element order is the root left right. If you consider any node, I mean any part of the node, it will be always in this format, root left right. If you just consider this particular node, okay, see 23 is the root right here, 23 is the root here, so 23, 26, since there is no right element, there is sorry left element, so 23, 26. If you consider this big node, full node, 35,
sir, okay.
23,
But what
26.
about post order, sir?
Huh?
What about post order, sir?
Post order will be just opposite. Post
Okay.
order, root will be at the end. I am not considering here the post order because we don't, for this particular question, we don't need post order.
Okay, sir.
Yeah, but how will you can find the post order, that will also I'll show you. Okay, after I build the tree, then I'll show you.
Okay, sir.
You can get also the pre-order, post order, in order specifically. Okay, now 36. Now, so our left part is done because this is our root. In order, the root will be somewhere in between, right? Because left, root, right. Okay, so in order we'll have something like this.
Okay,
Now so then next part is, so next is 13. Now right side we have to see again. When I am considering the right side, again 46 is coming, so 46 must be a root because again root left right. So from 35 we'll get 46. It must be a root. So we already got our answer. Pre-order, so what is the value of the right child of the root of the tree? That is 46. Correct, that is our answer. We have already got our answer, but we will make the tree and see. Okay, we'll make the full tree. It is interesting and it should, I mean you should learn this. Okay, then so 46 is my right, 46 is my root. Now 46, next one is 40, next verse is, so now we have to check if from 46 we have to check that what is with the next next root, correct, again, or it could be next would be a root. So again 46 is already done. Now let's go to the next one. So from 46, now if we have next two numbers are 40 and 39. So what should we do? It is always left right. So
why do you leave 39 beside, sir?
huh?
After 35, it's 39
No, I am
element.
considering here the pre-ordered
Okay,
tree. Yeah.
Okay, sir.
So from 46, I know that 40 is the root because after that the next two elements are 39 and 40 in the in order. So 39 and 40. So here I know the 40 is a node. So I am writing 40, and since it's the left to right order, so 39, and you know all the in the tree order, like whichever
Yes,
is
sir.
smaller, it will go to the left, which is bigger, it will go to the right.
Yes, sir.
So 40 is the next root, right?
40 is the next root.
So it shall be left of 46, no, sir?
Why?
It is
40 is
smaller
less
than
than
46.
46.
Smaller than 46, and
Oh
it
yeah,
is
yeah. Correct. 40 should be left. Correct. Yeah. Just let me think once. So after 46, next one is 40. No. Oh yeah. Correct. So after 46, next one is
Sir,
40.
then we have to look at in order traversal and select the left and left of
One second.
46.
I'll explain. One second. One second. So now from the 40, okay, this is my left and this is right. So this is I'm going
So we
left
go to
root right.
in-order elements, sir.
Hmm. Yeah, so my next no. So what I have to see here, see, we have to consider two things. What I have to see is that my next root is 40 and 39. If 40 is a root, if 40 is a root, then 40 will be 39 because next root is 40, right? So if 40 is a root, my in order orientation is left, root, right. So I have to give this, then this. You understood why I am copying for 39 here? Because 40 is a root. Now in order it should be left, root, right. So left, root. Okay, so now the 40 is my root, and then root. After that, see, root, left, then I am going again right. So
Little bit confusing, sir.
huh?
so right root shall be larger than right child shall be larger than the root, no sir.
No.
Here, yes, next root is
Yeah.
40, so it will be attached to 46.
Okay.
And
No.
next root is 39, it will be attached to
No.
40.
One second. Sorry. One second. So next root is 40. Then we have to go below. Correct. So 40. So we have to go below to 39 because if I'm going down, correct. Then after that, if 40 is a root, left. Yeah, I'm going to the left root. Then my right. So 40.
41 will be to the right of 40. Yes.
Yeah, 41 will be to the right of the 40. And
52 to the right of
no.
46.
Wait, one second. See, I have considered 40, 39 is done. 39 is a leaf. Yeah. Then from 40, yeah, from 40 again. So 40 to 40 is a root. So 41 to right. 52. 46 already done. Okay, so 46 already done. So
Okay.
41, 52.
Sir,
Correct.
52 is larger than 46 and it is left of 46.
Yes,
It
it
is
should be to the right of
It should be right
46.
of 46.
no.
Yes, sir. I think
This
we go to 46.
no. If we consider this part, it's not always right. It's not like that, right? From example 35, 23, 26. So
Your
we'll consider just from
sir,
the previous root, right?
in order 52 is right of 46, right?
Doesn't matter, right? Because 26 is okay. Oh, acha, you are saying
Uh,
no.
we have to take 46 as a base, 52 shall be right, 39, 40, 41 shall be on left. So we
No.
are left with 52, it will be at right of 46.
No. Wait. 1 second. Wait. So uh, if 40 is my root, just a second, I'll charge. I'll just charge the laptop. Yeah, okay. So just go back. Let's go back a little bit and clear our confusion. Okay. So we found that after 46, 40 is a root because we have 2, 39 and 40. So 40 should be a root. Then 39, 40, 41. So 41 is our 39, 40, 41. Okay, we are correct. So this is our another route. Now what we have to see that after 39, after so 52, where will we place? Okay. But see, that won't matter, right? Because even here, if you see, uh, 20, okay, it's always in the decreasing order. No, it's not.
Yeah.
It's not in the decreasing order, right? Because
No, sir, right child is always smaller, no, sir. So right child shall always be bigger.
right child is
Always
right
bigger.
child is
Always bigger.
right child is always bigger.
So even if you draw 52 from top, 52 is greater than 35, so it goes right. 52 greater than 46 is goes right. So finally it will be right child of 46. Actually, you marked up 35, no, sir. Then you demarked
But then
20.
40. Okay, if we
You
remove this,
didn't demark. You didn't mark 46. If you mark 46, then we can sell pay
see
39.
46.
You
46
didn't
is a
round off.
root. Okay, no, 46 is a root.
You round off in order also, sir. Like
No,
35 and 40. You
hmm.
round off 46 also.
Okay, if you are saying that 46, okay, 46 is a root.
Yes,
Okay.
39, 40, 41 R is left child, 52 is right child. Now next comes
Yeah,
40.
yeah, yeah. Okay. I understood. Yeah, sorry. Yeah, correct. Here till the 52 will go. Correct. Yeah. Yeah. So if we consider this one, hmm, okay, okay. Uh, okay, so last one, let's clear it once more. So we have a node, 46 is a node, 40 is another node, and after that 46, so left is 39, 41, and after 46 we have 52 here. If we consider this one also, 41, 46, okay, yeah, correct. So okay, so this is the tree, and so if you can always confirm a tree if you have made it correct or not by a simple left to right analysis. Okay, for that what we have to do is first we have to make the tree similar. Okay, so here you will, okay, we'll have to make the tree in the similar, like wherever there is a leaf missing we'll add a leaf. Okay, so here is a leaf, here are two leaves, here are two leaves, here are two leaves. Okay, now you should go from the left to right, you have to traverse. So whenever you touch a number for the first time, that is the pre-order. Whenever you touch the number second time while traversing, that will be the in order. Whenever touching three times, third time, it will be post order. So we'll write it pre, in, and post. Okay, so in pre-order will now follow. Okay, so first time we are traversing 35, so 35 is first time we are touching 35. Then we are traversing, first time we are touching 23, so our 23. Now we don't have anything, so we don't have anything, right? So we'll again touch 23. So in order first is 23, then we'll go back, we are not touching here, so we're touching 26. So first time we are touching 26, so 26 will come, correct? And then okay, 26 we forgot to have a tree, no, root. So then we to coming here, we are again coming back to 26, so 26 we are coming back second time, so this will be our 26. Now again we go back 26, we are touching for the third time. So okay, 35, first, yeah, so first thing of 26 will be 26. Then after that we are going back, touching 23 for the third time, so 23. Then we'll go back, and now we are touching the 35 for the second time, so that will be in order. Now when you are going back, touching 46 for the first time, so 46 will become in the pre-order. Again we'll go down, we'll go from left to right, so we are touching 40 for the first time. Okay, then we'll go back like this, we're touching 39 for the first time, so 39. Then we'll go back, we don't have anything, so we are again hitting at 39, so this is we are hitting at second time, so 39. Again you are going back, hitting this third time, so post order 39, we are hitting here, correct, we are hitting here for the second time, 40. Then we are going to the right side, first time we are hitting for the 41, so 41, we'll go back like this, we are hitting 41 for the second time, so 41. Again we are hitting 41 for the third time, so 41. Again we are hitting 40 for the third time, so 40, correct, like that. We're going 46 for the second time, so 46 in order. Then when going back to 52, okay, first, sorry, 46, okay, we have not touched the 40, okay, 41 we have, right, yeah, 41 we have touched, 1 second, I think,
Sir, you were at
52 first.
46.
yeah, I was at 46, so
Yes, 52 first time.
52 first time, correct,
So in pre.
in tree 50,
Yeah.
in the pre-tree it will be there, uh, so this actually won't be here now, still now, sorry. Then we are first time touching 52, it will be in pre-order. We'll go back, second time touching 52, 52. Third time touching 52, so here the 52. Third time touching 46, 46, and third time now touching 35, so 35. Oops. Where were we? 46 and okay. So if we consider at any point increasing order, yes, it is in increasing order. And why am I getting this out?
Sir, could you construct a 3 using post order?
Using the post order.
Post order,
Yeah,
sir.
yeah. Similarly, 1 second. I'll show. It's a similar. It's just 1 second. So this part is clear now. Okay, fine. Okay, this part is clear now. So this is our post order. Okay, let's try to build it with the post order. Okay, let's see. If we have so we don't have the pre-order tree here. We have the post order and the in order tree, right? So in post order again, we have, it's the similar way, we have to just go to the opposite side, right? We know the root is that right, so we have got the root. So here we have got the root. This is our first root. Now now we are again seeing, now we have to first consider a right part. Okay, first we have considered first the left part, now we consider the right part. We consider the right part, the next root is 46, so you have to check it, next root is 46. After that, either 52 could be either 52 either could be either root left or right. Now we know that for 52 is more than 46. So we'll put it at, okay, we'll put it at, sorry, I'll put 52. Yeah, correct?
Yes, sir.
Yeah.
Okay.
So next
So
would
how
be
are
an
we understanding that 46 is a root?
yeah, 46 is root because the order is root, left, right. So first is 35, then 46. It should be a root, right? It should be in the right, of course. It's increasing, and then it should be a root. Otherwise, why do I put this part? Because there are only four options. So you can always write it like this. You can always write it like this. So when we are first constructing, so in the right we have first what? 52, 46, 41, 40, 39, right? Now we
Yes.
consider what is there in the post tree. First is 52. Now if 52 is a root, then these all are uh, sorry, 35. After 35, what is this? First is 46. So 46 has to be a root. So then we can remove this all. Okay, 46 has to be a root because left root left right. After that 52, if 52 becomes a root, then it is not possible. For parts of 52 cannot go left because it's more than 72, sorry, more than 46. Then 52 cannot be a root also, because if 52 becomes a root, then this again goes in decreasing, which we don't want. So 52 is of course a leaf. Then the next root is 40. So we'll go and say, okay, the next root is 40. Now after that root, yeah. So after that 41,
Will be on the right.
yeah, 41 will be on the right, and will come to 39. Correct? So our order is fine. So we have already covered whatever we had in the, we have got 39, 40, sorry, this will be 40, 40 is a root, so this, sorry, my bad, this should be 40 is a root, so correct, 40 is a root here, so it should be 41. So my 41, 40, 41, 46, with all the right things are done. Now in the left side, if you consider the left tree, so there's the root 23 and 26. Now if you till 39 we are done. So now 23 has to be a root, correct? Because root, first root, then left or right, and then 23 is more than 26. Say 26 more than 20, so 26. Like that you will proceed. Okay, from the post order tree. So our one root is 40, 46, and another root is 23. Okay, is it clear? Okay then, so we are done with today's session, and then
Sir, I have to ask a question.
yeah,
I had enrolled earlier for this course, so I have the questions, a question paper of last year online exam. So in that there are questions in which the code is given, and we have to find the test case which will fail that code. So is there any particular
I am
method
not
to find out?
sure actually about that, because I have not, and we don't have any access to the previous year's questions, and or you can post it in the, I mean, if you want, you can post it in the discussion group.
Because
Like,
this paper will be on Sunday, and I think we will have
I
only
am not sure
on
like how it is done,
30.
because I have not enrolled any NPTEL course on previously, and
Sir, once show me the screen, sir. I will scrap it.
you want the,
Screenshot, sir.
oh, okay.
And sir, can you share the link for your previous sessions?
Yeah, it's already there in the in that PowerPoint, if you go for instruction for scholar sheet, here there will be everything will be there.
In the course, in the course page.
In the course, if you go in the course page.
No, actually, there are, I think 3 TAs are taking the sessions.
Yeah. So my name, if you consider my name, just Shobik Shom, mine is TA1. So you
Because
can, it will find
because
your
there
YouTube
only
links.
one by Jivesh Dikshit are available there.
No. This all the if you go.
Check sheets, madam. Different sheets are there. You
Different
check
sheets are
bottom.
there. Instructions for scholars. There is a sheet like instructions for scholars. One sheet. In that sheet, all of the TAs, all the YouTube links should be there.
Okay. Actually, for YouTube links, there were only 6 were being
If
shown.
you go in the not this one. If you go here, down, problem solving sessions. See, if you see here, I am viewing it with not my account. Okay. Yeah, so instructions for scholars is the sheet, right? There are Jivesh Dikshit C sheet 1 and instructions for scholars. Week 1 Shobik Shom tier 1. Week 1 of Jivesh Dikshit. Week 2 of my course. Week 3 of my session. Like that you will have till I have not. Week 7 of course you will have.
Okay. So you have your YouTube channel also, because
Yeah, I stream. I do like stream the. I do live stream of this all sessions of.
because I could find the lectures from the for Pratyush Talreja and this Jivesh Dikshit. I have subscribed that, but I couldn't find
Yeah,
it.
you can if you go in this YouTube particular link. I have my own YouTube. This is the YouTube my YouTube page only.
Okay.
It's not in my own name. That's all.
Excuse me, sir, I have a doubt.
Actually, sir, actually there is a different sheets are there. After instruction for the instructors, there is a sheet for Javed Dikshit sir and then the Pratyush sir,
Yeah. I
etc.
know, but always follow
Okay.
these instructions for callers. This is the main sheet. That's why it's skipped in the first one. Actually, we had some confusion. So first we actually had our
Okay, now it
own
is
sheets.
showing. Earlier it was showing only YouTube.
Yeah. We included this week or two ago. Because previously, all used to have our own sheets where we would give
Yeah,
our.
last week I had seen, so it was showing only.
Yeah. We all have our own sheet also where also we have all the links. But this is where we have the links for everyone. Okay.
Okay.
So you can go either you can see this or for my own sheet like that you can see.
Okay.
Excuse me, sir, I
Yeah.
have a doubt actually
Hmm.
with another course. Actually, sir, I have applied for a 12-week course on NPTEL, but due to some reason I wasn't able to submit my assignment for first 4 weeks. So if I start now, so can I get all 25%
I am
marks?
not sure about these things. This we are taking for a
Okay,
different course. I am
okay,
not
okay.
someone which will
Eh,
be
eh,
able to answer this
You
Maybe,
have
thing.
to
sir.
follow the deadline.
No, actually, I was unable to submit for 4 weeks.
That is not a matter. You have to fulfill the
Yeah, if you
requirement.
have to submit within the deadline, as per I have
You have
seen, if
to
you
follow
don't
that.
submit in the deadline for this course,
Yes.
actually the submission uh, window is locked, so you cannot do
No,
anything.
yes, sir, I know, but I was asking for if for the remaining 8 week, if I submit on
Yeah, that
time
will be
with,
fine because you
okay,
need
that will
to
be fine.
complete 8 out of 12.
Huh.
8
Okay,
out
okay,
of 12.
okay,
So that your score will be counted from there.
okay. Thank you, thank you.
75% assignments you have to.
Y- Yeah, okay, thank you.
Okay then, so see
Thank
you
you, sir.
next week for the last session for
So
this.
one more doubt.
Okay,
So post-order traversal is actually left, right, and route, or right, left route, sir? What is the order?
right, left, root.
Right, left route.
Yeah,
Okay.
right, left, root or root,
But
left, right.
we have started from left. No, sir. 26 and so 23 and 26 are actually left
No,
side of this in that screen.
huh?
They are
26 is the
actually.
route and
26 is
20.
right, right? 26 is right, right? 20. One second.
We don't have leave.
One second. One
That's
second.
why. We don't have left leave. That's why we gone to
That's why
26.
we have started on the We don't have left leaf, right? So that's why we started on the 26.
Right.
26 is right. Then we have
But,
root. Right? Left is not there. Root.
Suppose if we have 21 below
Huh.
23, then
Huh.
we'll
Then
start
we
with
would have another thing is like this. So then we would have
21. Then we'll
then
start
we'll have
with 21.
26, then sorry, we'll start at 21. Oh, sorry,
Yeah.
26, 21, 23. So here it will be the 21.
No, sir. Actually, third time we'll touch. I mean, first we'll touch 21 3 times before reaching 26.
One second.
So, draw two empty leaves.
One second. Let's see.
Yes.
Yeah. So if we draw two leaves, first 35,
23, 21.
35, 23,
21.
23. Then we'll have
empty.
yeah.
Now
So
second and third.
we'll have 3.
So it is like left, right, and root. Correct, no, sir?
No, it is not left, right, root.
But
It is
21.
left, right, root. Okay, one second. Okay, I'll just confirm it. 1 second. I'll just confirm it with the.
Okay.
Just 1 second. Give me 1 second. I'll just confirm. I may be confused. 1 second.
Okay, sir. Wait.
Let's see. I may be wrong. I'll just check once. Yeah, you are correct. I'm sorry. It's correct. Pre-order is correct. You are correct.
Okay, sir. Okay, I have.
Yeah. You are correct. I'm sorry. I made it wrong.
Okay, thank you, sir.
So this one should be actually just a second. So this one actually should post order would be left, right. I'm sorry. This I got confused. Yeah, left, right, and row.
Okay, sir.
Screen is not sharing, sir.
It's not sharing. It's
Yes,
sharing,
sir.
right? Oh, okay. Yeah, it should be left, right, root. My bad. Sorry. So 21 actually. 21 actually should be here. Okay. Yeah.
Sir, when we will have our last problem solving session?
Next week.
Next week on Tuesday.
Next Tuesday.
Friday. Or
next Friday. Friday there will be 2, and Tuesday will be the last. Next Tuesday.
Okay, because Friday there will be.
There will be 2 sessions.
And I have joined another course, so for that there is exam on top.
Okay then. Goodbye. See you in the next week.